Okay guys, so welcome to today's class. We'll be looking at limits of a function, all right? So we have exercises, about 6 of them on the board, of which we'll be evaluating, all right? So we'll be evaluating these limits in different contexts. And I want to remind you that a limit is actually a value, okay, that x tends to or x approaches in a given function. When we say limit, we are talking about an extent. If I want to say that my limit for today, for doing a particular thing today, is 2 p.m., it means that by 2 p.m., I should have stopped working. You've heard statements like, the sky is your limit, right? It means that when you get to the sky, that's the final point. Don't pass the sky. Because now you know what you they go find above the sky. But people later said that the sky is your starting point. Which means that anything you're doing on earth here, it's not counting. When you get to the sky, that's when you need to start counting. Then you from there go to the moon. Above the sky, you explore the universe. That one is when we talk about physical limits. Here we're talking about mathematical limits. It's not far-fetched. So when we say x tends to a particular value, it means that x is approaching that value. X is approaching that value. Now if you look at number 1, say lim as x approaches 2. Lim as x approaches minus 1. X approaches 1 over 2. X approaches infinity. X approaches infinity. X approaches infinity. 6 questions. Now, there are major ways of evaluating limits. Okay? There are major ways of evaluating limits. For a start, we are going to look at the first 3 ways of evaluating a limit. Now, the ways of evaluating a limit, we have direct substitution. The first one is by limit by direct substitution. The second one is L'Hopital's rule. L'Hopital's rule. The third one is limits by factorization. We have factorization. Then we also look at limits to infinity. Limits to infinity. Then we also have what we call limits by rationalization. Limits by rationalization. So for a start, we are going to look at 1, 2, and limits to infinity. Alright? But to progress, we look at the remaining ones. Okay? So I'm just going to throw lights on this. I'm just going to make a crude emphasis and a crucial one on these techniques in evaluating limits, of which we are going to use these exercises. Alright? So we have direct substitution, L'Hopital's rule, factorization, limits to infinity, and limits by rationalization. Alright? Now when it comes to direct substitution, okay, when it comes to direct substitution, we substitute the value that x tends to into the function. We substitute it directly into the function. That's the pattern. That's the pattern. Is that okay? Alright, so are we done writing this? Okay, so I'm going to be using here to evaluate. We have direct substitution, we have L'Hopital's rule, we have factorization, we have limits to infinity, and we have limits by rationalization. Alright? So now we have the first exercise. Now the first one, we are being told that the limit as x tends to 2 have a function x squared plus 16x minus 3 divided by 2x plus 4. Are we together? Are we together? Now, so what we are going to do, look at the value 2. We'll substitute 2 into this function. So wherever we see x, we replace it with 2. So we say 2 squared plus 16 times 2 minus what? 3. divided by, I can clean this, right? Divided by 2 times 2 plus what? Plus 4. Are we together? So now, 2 squared is 4, right? 16 times 2 is what? 32. 4 plus 32? 36. 36 minus 3? 33. Divided by 2 times 2? 4 plus 4. So our answer is 33 over 8. Alright? So, by direct substitution, we have 33 over 8. So direct substitution is not usually an issue because what you just have to do is to substitute the value of x into the function. Is that okay? Okay, so quickly we'll be doing the second one. Now it's still the same pattern. Alright? We have lim as x tends to minus 1, 5x squared plus 8x minus 2 divided by 2x plus 2. Alright? So, but before that, I want you to actually understand that there is what we call continuity and discontinuity of limits. I will explain that. Alright? There is what we call limits do not exist, limits is undefined, limits tends to infinity, limit is at infinity. I will explain all of those concepts. By the time we are done solving this number 2, you will see something. Now, we have 5 brackets minus 1, right? All squared. Plus 8 times minus 1 minus 2. Divided by 2 times minus 1 plus what? Plus 2. Are we together? Alright. So now look at this, guys. This will now be equal to minus 1 all squared is 1, right? So 5 times 1 is what? 5. Plus 8 times minus 1, minus 8, then minus 2, divided by 2 times minus 1, minus 2 plus 2, equal to 5 minus 8 minus 3, right? Minus 3 minus 2, minus 5, over minus 2 plus 2, 0. Now this is not your final answer. If you put this minus 5 by 0 in your calculator, it will give you math error. It will give you math error. Minus 5 divided by 0. Math error. 0 over 0. Math error. So calculators will show you syntax. Syntax what? So how do we resolve things like this? We find ourselves in this kind of situation. Do we cry? Do we close our books and say, no, we are not continuing? There is a solution. Tell anybody there is a solution. Alright. So minus 5 over 0 is not the final answer. Whenever we have 0 over 0, a number like this, minus 5 over 0, 8 over 0, any number over 0, it means that that limit is undefined. That limit is undefined, or we say does not exist. Or we say does not exist, or we say infinity. The limit is, evaluating the limit is infinity. Please don't confuse this with x tending to infinity. The limit itself is infinity. It does not mean that x is tending to infinity. That one is a different technique altogether. But when you have this, how will you go further? Now, when you have this, you go further by using what we call the L'Hopital's rule. That brings us to the second technique, which is called what? L'Hopital. L apostrophe H-O-P-I-T-A-L apostrophe S. L'Hopital's rule. Now, the L'Hopital's rule is the rule of differentiation. It's the rule of what? Differentiation. Alright. So, what it means is that when we have an answer like this, we should not conclude that it's our final answer. We use the L'Hopital's rule. Remember, I told you that all of this, something like this, means that it does not exist. Anytime that your denominator, the shortcut is this. Whenever you have a question, don't go straight to using L'Hopital's rule. The shortcut is this. Text your denominator. If your denominator gives you 0, it means that what you have to use is what? L'Hopital's rule. It means what you have to use is L'Hopital's rule. Alright? So now look at this. Okay? So the question was lim as x tends to minus 1. Then we have 5x squared plus 8x minus 2 divided by 2x plus 2, right? This was the question, right? Good. So now, after you have done this, use L'Hopital's rule to differentiate. Now, what is the rule of differentiation? Power rule of differentiation is that if we have AXN, to differentiate is n times a x raised to power n minus 1. Are we together? N times a x raised to power n minus 1. So the idea is this. We are going to differentiate both up and down. Please, did we use L'Hopital's rule here? Why? Yes, because denominator is not 0. Thank you. Because denominator is not 0, so we did not need to use L'Hopital's rule. Are we together? Alright. So now we have to clean this. We have to clean this up. And now differentiate. We'll differentiate. So let us differentiate the top. The idea is that whenever you are differentiating, multiply the power by the coefficient. Multiply the power by the what? Coefficient, then subtract 1 from the power. 5x squared will give us 10x. Whenever you have something like this, 8x, you have a function like this, and x does not have a power. You remove the x, and you take only the coefficient, so this will be plus what? 8. Then how about minus 2? Minus 2 is a constant. Whenever you are differentiating a constant, your answer is what? 0. Whenever you are differentiating a constant, your answer is 0. So it means that we have 10x plus 8 divided by, let's do the same thing here, 2x. X does not have a power, right? We discard x, so our answer is 2. This 2 you're seeing here is a constant, so it is what? 0. We are using this, look at the rule we are using. AXN, 5x squared. Your a is your coefficient. Your n is 2. Multiply 2 by 5, you have 10. 10x, 2 minus 1 is 1. So it's just you saying what? 10x. Are we following? Alright. So, it means that after we have differentiated, remember, it's still this question we are working on. After you differentiated, now substitute that value that you had into the function again. So this will be 10 times minus 1 plus 8 divided by 2. 10 times minus 1 is what? Minus 10, right? Minus 10 plus 8 will give you what? Minus 2, right? So minus 2 over 2 will give you what? Minus 1. This is our answer. So that's our final answer. Yes, simple. L'Hopital's rule is just the rule of differentiation. Is that okay? Alright. So, look at number 3. I would like you to try number 3 quickly. Alright. So number 3 says lim as x tends to 1 over 2. We have 2x minus 6 divided by minus 16x plus 8. So please solve this quickly. Alright, so if you solve number 3, okay, the one I just told you to attempt, your answer should give you minus 1 over 8. Minus 1 over 8. Alright? So now let's look at from number 4 to number 6. If you look at these limits, you realize that they look different from what we have been doing between number 1 and 3. Alright. If you look at it very well, you realize that x is tending to infinity. X is tending to infinity. Now, how do you resolve this? I will even give you the shortcut to approaching this. But now, look at what it means. Whenever x approaches infinity, are you hearing me? Whenever x approaches infinity, divide the numerator, everything in the numerator, by the highest degree of x. X and its highest degree, as well as the denominator. Now look at what I mean. Let's look at number 4. Number 4 is lim as x tends to infinity. Then we have 5x squared plus 18x minus 3 divided by 6x plus 12. I'll give you the shortcut for this. But now, if you look at this particular limit, you realize that we have x squared and we have just x, right? Now, the highest degree here is the one in which x has the highest value as its power. Which one has the highest power of x here? 5x squared, right? If you look at all these ones are just x raised to power 1. Take the variable of x that has the highest what? Degree or power. Are we together? So, but you're not supposed to include the coefficients. Only take x and its highest power. Only take x and what? Its highest power. Alright? So, at this point, what we'll do is this. Divide both numerator and denominator as I clearly stated. So this will be 5x squared. Divide it by x squared. Come to 18x. Divide 18x by x squared. Come to minus 3. Divide minus 3 by x squared. Are you seeing what I'm doing? Then you bring this long division line. And you come, do the same thing to the denominator. 6x over x squared plus 12 over what? X squared. Only take x and its highest power. Don't take the coefficients. Don't divide by 5x squared. Are we together? Don't divide by 5x squared. Only divide by what the x is and its highest power. Just take x and the highest power of x. If for instance, here we are to be, if we have something like 6x cubed, you only divide everything by what? X cubed. Look at number 5. What's the highest power of x here? We'll divide everything by what? What's the highest power of x here? We'll divide everything by what? X cubed. Alright? So now, so that is that. Now after dividing, the next thing is to what? The next thing is to cancel, okay? The next thing is to cancel out. X squared will cancel x squared, right? If x cancelled x here, x squared, how many will remain here? X will remain, right? Do you understand? If x cancels this x squared, how many x are here? X times x. So it's only one x will remain. Is there anything that can cancel here? No, come here now. If x cancels here, how many will be left? X. So now after doing that, you can now substitute infinity into the function. Alright? But now, this is what you have left. When x squared cancels x squared, you'll be left with what? 5. So you have 5 plus 18 over what? X minus 3 over x squared divided by 6 over x plus 12 over x what? Squared. Now, having done this, what you have to do next is to now substitute. So when you substitute, you have something like this. 5 plus 18 over infinity minus 3 over infinity what? Squared. Anywhere you see x, substitute infinity into it. Divided by, I hope you are following. Divided by 6 over what? Infinity plus 12 over infinity all squared. Now, if you look at this, we have substituted infinity. Whenever you substitute infinity into a rational expression, everything there automatically becomes 0. Whenever you substitute infinity into a rational expression, everything there automatically becomes 0. So it means that we have 5 plus what? 0 minus 0 divided by 0 plus 0. What will we get as our final answer? 5 over what? 0. And anything divided by 0 is what? Infinity. So I think we are coming back to infinity. Like I said, anytime infinity is substituted into x, in a rational expression, everything there becomes 0. Anything divided by infinity is 0. Alright? So at the long run now, we now have 5 minus 0, 5 plus 0 minus 0, and the final answer is infinity. Alright? What is the question? We use what? No. You cannot use L'Hopital rule here, please. No, you cannot use L'Hopital rule here. Alright? We only use L'Hopital rule when we have a limit that x is tending to a number, not infinity. We don't use L'Hopital rule for infinity. We use L'Hopital rule for only the one where x is tending to a value. If x was tending to -2, okay? If x was tending to -2, and when we did direct substitution, it gave us anything over 0, then we'll use L'Hopital rule and solve further. But in cases like this, we don't use L'Hopital rule, because if you use L'Hopital rule and you differentiate it, you still carry infinity and what? Put inside. And it will still arrive at infinity. So just solve it straight. The rule is that you should divide by what? You should divide by the highest power of x, highest degree of x, both up and what? Down. Does that make sense? Is that clear? Alright. So if you are here probably when I was explaining the L'Hopital rule, you would have gotten it clearer before asking, okay? But please don't forget, it is only when we have a number that x is tending to. Alright? Only when we have a number that x is tending to. Okay. So now, let me give you a trick. Let me give you a trick. Now, there are 3 cases for infinity. Are you hearing me? There are 3 cases for infinity. When the highest power of x, listen, when the highest power of x is at the numerator, when the highest power of x is at the numerator, your answer will be infinity. When the highest power of x is at the numerator, just know automatically if it's an objective question, shortcut to this, just go and look in the option where is what? Infinity, tick, and go your way. Don't solve. Whenever the highest power of x is at the numerator, it will always be infinity. Now that's number 1 shortcut, number 1 case. Number 2 case, whenever the highest power of x is at the denominator, whenever the highest power of x is at the denominator, your answer will be 0. Your answer will be what? 0. Your answer will be what? 0. Whenever the highest power of x is both at the numerator and at the denominator, your answer will be the ratio of their coefficients. What do I mean? The answer to this question will just be 9/3. And 9/3 is what? 3. So whenever the highest power of x is both at the numerator and the denominator, your answer would just be just pick the coefficient, divide the coefficients of those highest powers. Highest power here is x cubed, right? It's still x cubed here, so 9/3 is the answer. So just go to the option and tick. That's the shortcut. Instead of going through all this solving, but it's still necessary that you know this process. So it will help you in case you see this kind of question as a theory question, so you can be able to solve accordingly. All right. So now let us solve the number 5. Lim as x tends to infinity, 2x squared plus 18x minus 4, and all of that. All right. All right. Please hold on with your question. Hold on. Oh yeah, ask quickly. Ask. You don't have a question. All right. So we'll be looking at the next question. All right. So we have lim as x tends to infinity, 2x squared plus 18x minus 4, x cubed minus 16x squared plus 9x minus 3. All right. So quickly would be resolving that. I believe we are done writing this, right? I still putting this down. Okay. So we have, please don't forget the shortcut I just told you. Don't forget it. If x has the highest power at the numerator, if the highest power is at the numerator alone, don't bother if it's an objective case. Okay, don't stress yourself. The answer will be infinity. If it's at the denominator, the answer will be 0. If it's at both the numerator and denominator, just the coefficients. Just the coefficient, ratio of the coefficients. Okay? Alright. So now, we have link as x tends to infinity. We have 9x cubed plus 18x squared plus 12x minus 3 divided by 3x cubed minus 16x squared plus 55x minus 8. Okay, so what do we do here? Okay, I think we have jumped to number 6, right? Not bad, let's just solve it at home. Okay? But remember I told you that when you have both up and down, it's just the coefficient, right? Yeah. But now let's just do it the way we have been doing it. So divide everything. So 9x cubed, divide it by x cubed plus 18x squared over x cubed plus 12x over x cubed minus 3 over x cubed divided by 3x cubed divided by x cubed minus 16x squared over x cubed plus 5x over x cubed minus 8 over x cubed. X cubed cancels x cubed. If x squared cancels x cubed, how many will be left here? X. If x cancels x cubed, x squared will be left here, right? If x cubed cancels x cubed, all gone. X squared cancels x cubed, x will remain here. X cancels x cubed, x squared. Are we following? Are we following? Don't mind the fact that it's scattered, okay? But it's just the whole solving of the thing. X cubed will cancel x squared. X squared, x cubed. X will remain here. X cubed, x squared will remain here. Alright? X squared, x cubed, x will remain here. X cubed, x squared will remain here. Alright? So now, if we should proceed, it means that we would have x cubed cancel x cubed. How many will remain here? 9, right? So this will be 9 plus 18 over x plus 12 over x squared minus 3 over x cubed, all divided by 3, there's no minus here, please, 3 minus 16 over x plus 5 over x squared minus 8 over x what? Cubed. Remember I told you that whenever we substitute, because that's what we want to do now, substitute your infinity into x. So whenever you substitute your infinity into x, that becomes what? 0. So this will be minus 9, sorry, this will be equal to 9 plus 18 over infinity plus 12 over infinity all squared minus 3 over infinity all cubed divided by 3 minus 16 over infinity plus 5 over infinity all squared minus 8 over infinity raised to power 3. Okay? Alright, so this will be equal to 9 plus 8, okay, yeah, 0, right? Impressive, you're following. Plus 0 minus what? 0 divided by 3 minus 0 plus 0 minus 0. What do you have left? 9 over 3 will give us what? Alright? So that's the perfect approach to this. That's the perfect approach to this. So, like I said, just know the shortcuts to this. And if it is not theory, if it's objective, just look for the right option. Okay? Just look for the right option. So we have lim as x tends to infinity. 2x squared plus 18x minus 4. X cubed minus 16x squared plus 9x minus 3. So I want to give you as an exercise. Try this. Prove that your answer will give you 0. So prove it. Remember, I told you that you're done, right? Beautiful. Impressive. So, like I told you, if the highest power of x is at the denominator, automatically your answer would be 0. So prove it. Okay? Prove it to me. Alright, so if you've not subscribed to this channel, do well to hit the subscribe button, share this video as well, and like. And if you have any question whatsoever, ask your question in the comment box below. Thank you and see you in the next class.